Hi, I am Angela Mark P. Walag, and I'm honored to present our paper entitled Virtual Chemistry Laboratory for Methods of Separating Mixtures, a design, development, and evaluation of a mobile application on behalf of my co-authors. This presentation would follow this sequence. I'd like to begin with a brief background, methods, salient findings, conclusions and implications, and of course, references and some acknowledgement. The main goal of science education is to develop scientifically literate citizenry. This goal has been disrupted by the COVID-19 pandemic as teachers have difficulty learning new pedagogies and other learning modalities. This can be addressed by integrating information and communication technology tools available to make teaching and learning of science interesting and engaging. Despite the advancement of using ICT in the classroom, teachers continually report that they face many challenges in using them in the science classroom. One problem highlighted was the use of ICT tools are only limited in routine type of tasks like sporadic and mechanical retrieval of information from the internet. This suggests that the use of ICT in science education do not automatically translate into better science teaching. In addition, much of the problem is laid down to teachers, particularly in how they select and evaluate appropriate ICT tools to integrate in their science classes. One of the most common ICT tools used widely in education are mobile applications. The availability of more smartphones has made it possible to use and expand mobile-based educational initiatives. Currently, the usage of mobile technology is changing and altering traditional and conventional classrooms into one that is more participatory through applications that boost students' learning. Additionally, mobile learning gives students the chance to participate in learning activities that are problem-based. Moreover, when utilized as a component of blended learning, mobile applications may be used in the classroom effectively. Chemistry is frequently viewed by students as an extremely difficult rite of passage on their path to reaching numerous careers in science, technology, and mathematics. The same writers also asserted that learners struggle because they only remember data and formula rather than comprehending the ideas and honing their basic problem-solving abilities. As such, chemistry courses in both basic education and higher education curricula have laboratory components. The laboratory component of the general chemistry course has long been regarded as a crucial component in the curriculum. The theory discussed in the lecture should be grounded in laboratory exercises, which foster the technical hands-on skills required of STEM workers. One challenge with laboratory instruction during COVID-19 pandemic is access to school laboratories while ensuring health and safety regulations are observed. Modern and advanced education institutions address this challenge by employing a hybrid setup, kitchen chemistry laboratory setups, online laboratory classes, and virtual laboratory setups, to name a few. Lab courses that are tailored for online delivery include class materials and activities that have been carefully planned to provide students an experience that is comparable to using the lab in person. As such, designing remote laboratory activities require tailor-fitting it to students' needs instead of a one-size-fits-all approach. This study aims to design, develop, and evaluate a virtual chemistry laboratory mobile application to teach methods of separating mixtures for high school students in the Philippines. This study utilized a design and development research design, and the process is summarized based on the design framework as shown in Figure 1. The virtual chemistry lab mobile application for methods of separating mixtures was designed based on different recommendations found in the literature. Based from the interface and features of the app design, the application was developed by application developers from the university. The application was then subjected to alpha and beta testing by experts in IT, chemistry, and chemistry education to identify glitches and inaccurate concepts found in the app. After the validation, the app was then evaluated by one INTA class in a nearby public secondary high school in the city. The interface design of the application is shown in Figure 2. Once students open the application in their mobile phones, they will be welcomed by the home page shown in Figure 2A. In this home page, students can choose which methods of separating mixtures will they be learning and operating in the app. The application mechanics is summarized in the following steps. The students will be prompted to choose which methods of separating mixture activity they will perform. They will be able to tap the icon of the respective method. They will then be redirected to the respective page of their chosen method as shown in Figure 2B to 2H, and then the students can also tap the label icon encircled in Figure 2B. This label icon, once tapped, will provide labels to the different lab apparatus and equipment necessary for the laboratory activity. Students can also opt to tap the flask icon encircled in Figure 2C, which will then provide the necessary procedures for students to follow when performing the activity. To operate the procedure, students will only need to drag and drop the different lab apparatus in the right places and set up for it to run automatically. Once students are done performing the activity, they can tap the quiz icon encircled in Figure 2E to be redirected to practice quiz for their respective laboratory activity. The VCLMA was evaluated using the researcher-made evaluation rubric and the intrinsic motivation inventory. The researcher-made application evaluation rubric was utilized by 5 chemistry teachers to evaluate the VCLMA, while students answered the revised IMI in terms of activity perception. The researcher-made application evaluation rubric is composed of the accuracy of concept, attractiveness, function, accessibility, and interactivity, and is shown in Table 1. It was subjected to thorough content and phase validation by chemistry and science teachers, and then the instrument was then pilot tested for reliability and validity. Krippendorf's alpha was utilized as the inter-rater reliability measure, and the instrument was found to be reliable at alpha 0.082. The results are summarized in Table 2. As shown, the VCLMA has been rated very good in the accuracy of the concept, accessibility, and interactivity, while good in attractiveness and function. It is noteworthy that the application has been rated highest in both accessibility and accuracy of the concept. This is significant because encouraging student participation in the learning process through interactive features is another way that technology may be effectively integrated into the classroom. It has been demonstrated that integrating interactive technology into education can improve learning in traditional classroom settings. Furthermore, mobile devices should help learners learn rather than complicate their learning process. Accessibility was also given a very high rating, which is crucial since mobile applications should be widely available and simple to use in order for it to be effective in science teaching. Current mobile apps also emphasize the value of ubiquity, mobility, and portability as they help the learning process. This very good rating for accessibility can be due to the fact that the VCLMA does not require internet connectivity for it to be operational. The teacher evaluators scored the app at least at the function criteria. The application's function may differ depending on the type of mobile phone being used, which may account for the lower score given. Instead of utilizing a mobile device with an app pre-installed to verify functionality, the evaluators were requested to download and install it independently. Consequently, the app was scored in a more accurate manner. In light of this, it was discovered that the application's functioning varies significantly depending on the make and the model of the phone being utilized. As shown in Table 3, students reported to agree most that the activity was fun to do and it is important. This is crucial since motivation has been recognized as one of the core components of learning. Students who are intrinsically motivated are more likely to stick with challenging assignments and make amends for their faults. Students are also more likely to recognize the importance of a theory when they can apply it to their daily lives. Furthermore, When students have fun while making sense of the learned content, it enhances their conceptual understanding and motivation. Consistently, students reported to least agree that the application was boring and that they had no choice to do this activity. It is essential to employ constructivist-based and student-based instructional materials since the majority of scientific lessons content is abstract and teachers find it challenging for children to understand. This means that more thoughtfully created materials provide pupils a chance to express their cognitive preferences. Allowing pupils to readily express their genuine feelings can also improve learning. All of these point to the possibility that the many features and functions of the mobile application inspire students to be motivated learners. The goal of this study was to design, create, and evaluate a mobile application which could be used as a virtual laboratory activity on methods of separating mixtures for high school students. Based on the results, respondents reported that the VCLMA is engaging and attractive. Students reported that the activities in the VCLMA is fun and important. These positive evaluations are essential as these are prerequisites to meaningful and engaging learning. Furthermore, these positive results provide an important generalization that mobile applications, when designed with learners in mind, are beneficial to both educators and to the learning process. This work was supported by the University of Science and Technology of Southern Philippines. Here are the references utilized in the study. Thank you very much, and I'm now ready for your questions, comments, and suggestions.